Good evening and welcome to this AHDB webinar, an introduction to slurry cooling. My name's Ben Williams and I'm the AHDB Pork Knowledge Transfer Senior Manager. Before I introduce the aims of the webinar and our speakers, just a couple of housekeeping items. First of all, this webinar is being recorded, so if at any point you lose connection or you have to dash off for an emergency, it will be available later from the AHDB website. You'll notice that you're all muted, but there is still an option to chat and ask questions. So please ask your questions. What we'll do is we'll keep a note of those. We may be able to respond to some of them as we go through, but what we'll do is we'll direct questions to our speakers at the end of the delivered talk. Just to support any questions, queries, or follow-ups, you'll notice that there is in the options a section marked handouts. Within that, there is a handout to support this webinar that includes further learning materials available from AHDB and documents that are quoted and relevant to the topic of slurry cooling. Just a point of note, at the end of the webinar, it does seem to cut off a little bit abruptly. Don't be alarmed. We've not just sort of harshly cut you off. Unfortunately, that is how to go to webinar ends. And I suppose, given the heat, just a personal point, if you have the opportunity to top up your drinks with something cold and refreshing, now is probably the time to do it. So the AHDB webinar today is an introduction to slurry cooling. The aim is to summarise the current industry pressures to which slurry cooling may be a solution and provide an overview of this technology and hear about the practicalities of installation and use. I'm joined tonight by Zanita Markham, who's the Environment and Buildings Officer for AHDB, John Swain, who's the Technical Director for NFU Energy and has looked after our GrowSave work, and Kasper Holgersen, the Agro Marketing Manager from Climadan, who brings practical experience of installation in the field. We'll start tonight with Zanita Markham, who's going to set the scene for us about the current state of buildings and investment and ammonia legislation within the UK. Over to you, Zanita.
Thank you for the introduction, Ben. So I'm going to start us off this evening by taking us back to last year and sharing a few learnings from the AHDB Building Survey. So the survey was conducted to look at the current condition of pig buildings in England and producers' attitudes to investment in new buildings and associated technologies. If we compare the survey to the previous survey, which was carried out in 2013, the age range of pig buildings remains, with the majority being over 20 years old, and the feeling over financial investment remains, showing us that there is the desire, but the considerations and uncertainty over areas of legislation remain as barriers to large investment. We don't have time this evening to run through the whole of the report, but I have selected a couple of standout points to look into. The graph that you can see on your screens shows us the biggest barriers to investment. I'm not going to discuss Brexit in too much detail here, but we must be mindful that at the point of surveying, it was very much on our minds. Given the nature of the topic, AHDB are continuing to develop holistic resources on Brexit. But what we can discuss are the barriers related to the environment and the expectations of producers to make changes to be able to improve their businesses. If we break this down a little bit more, independent breeder to finisher enterprises are most concerned about this area. We are seeing where there is large investment, it is investment of new builds and technologies. There is a commitment by pig producers to adopt housing and management systems which deliver high standards of animal welfare and comply with legislation, such as those set out to protect the natural environment. This is likely to be because just over half of producer surveys wanted to future-proof their businesses, making them sustainable to pass on to the next generation. Now, I appreciate that this is just a sample of industry opinions, I think it's fair to say that those opinions are felt all over the sector, with the uncertainty of the future whilst we live through these unprecedented times. Next slide, please, Ben. So why are producers concerned about environmental legislation and having to produce an environmental impact assessment? So let's start with the Clean Air Strategy. So this strategy was published last year and came into place because air pollution is the top environmental risk to human health in the UK and the fourth greatest threat to public health after cancer, heart disease and obesity. The UK also has statutory obligations to keep concentrations of specified pollutants below certain levels, as well as national emission reduction commitments for overall UK emissions of 5 damaging air pollutants. Unsurprisingly, the top of the list is ammonia. The national emission targets set ambitious reduction goals for 2010, 2020 and 2030. The UK has met the current targets since 2011, and I'll cover what the targets are a little bit later on. So what is the issue around agriculture and ammonia? The image that you can see on your screens really highlights some of the key messages. So agriculture as a whole is responsible for 88% of UK emissions of ammonia gas, which is emitted during storage and spreading of manures, slurries, and other inorganic fertilisers. And there's a lot of issues surrounding this. The issues can be placed into two strands, either by affecting human health or damaging our natural environment. Ammonia is a gas that is emitted into the atmosphere and then either deposited back onto land or converted into secondary particulate matter through reactions in the atmosphere. So it can, in a sense, over-fertilise our natural habitats with nitrogen and combines with other pollutants to produce a fine particulate matter pollution. And it is this particulate matter that is what is of concern around human health, as it can get into our lungs, affect our respiratory systems, heart, brain and other organs. The strategy sits alongside other important UK government strategies, including the 25-year Environment Plan. Next slide, please. So this graph shows us the progress made in reducing emissions to air up until 2016. It's the lighter green line that we're looking at here to concentrate on ammonia. This shows us that ammonia has fell by 13% between 1980 and 2015. However, since then there has been an increase of 3.2%, and this is largely due to fertiliser use. The aim to reduce emissions of ammonia against the 2005 baseline is by 8% by 2020 and 16% by 2030. Next slide, please, Ben. So we've seen a lot about emissions from agriculture as a whole. So I'm just going to show this pie chart, which shows emissions from pigs. The one on the left-hand side shows us that 51% of emissions are from livestock, and you can see that pigs account for a smaller proportion of total livestock emissions. But this does not mean we can't and shouldn't still play our part to push down these figures. There is a lot of emphasis on how to do this through muck spreading and housing. Kasper's ammonia emission inventory tells us that 54% of emissions from pigs is from housing. So targeting these areas is really what's going to make the biggest difference. This year's farm practices survey from DEFRA tells us that 42% of livestock holdings have slurry stores, and currently 24% of tanks are covered. However, this figure does include pits under slatted floors. And let's also not forget those farms under an intense environmental permit. So the best available technique reference document was published in February 2017. The UK has 4 years to ensure that we are compliant with the measures set out in the BREF for both new and existing planted sites. That deadline is fast approaching, so it's February next year. One measure that needs to be resolved is the emissions of ammonia from pig housing. The BREF has published associated emission levels for ammonia emissions to air. UK pig emission factors are used both for habitat assessment and pollution inventory reporting. So now we know the targets, what and how are we going to do something to reduce emissions? We're together tonight to explore slurry cooling as a means to reduce emissions. Now, if we take a look back at their building survey, producers were asked what they felt AHDB's role was in supporting to improve investment into buildings and technologies. 3 themes really stood out, so funding, communicating and engaging with producers, and providing technical information and evaluation. AHDB has acted on some of these findings. We fully acknowledge that buildings are key to productivity, health, welfare, and ultimately the success of the industry. Next slide, please. So a revamp of the website is now underway, allowing us to create, maintain and update a technical hub of information for producers, covering all aspects of production. A couple of our newer resources are around slurry cooling and ammonia reduction. They're displayed on your screens, so it includes a new animation to tell you all about slurry cooling in a very brief, concise way. And links to those documents and the website links can be found in your handouts. But what perhaps isn't visible is the work behind the scenes. Let's tackle funding first. So AHDB engages with grant funding providers in an advisory capacity to ensure that technology which enables increased productivity and reduce emissions become grant funding options. An example of this is with the Small Capital Grant Scheme. Where we are most effective is working with regulators and stakeholders to discuss practical trials and research to address the lack of up-to-date information, including reviewing the existing pollution inventory figures. We are also facilitating talks between welfare policymakers and building suppliers to encourage these conversations early on. So focusing on the lack of up-to-date information or readily available information, we're going to showcase this tonight. So AHDB has linked with GrowSave. So pork brand new to that, as well as some other sectors which have been have a bit of a legacy piece with GrowSave. So I'm now going to pass you over to John to tell us all about GrowSave.
Thank you very much, Zanita. So yes, as Zanita's mentioned, we're now joined by John Swain, who's NFU Energy's Technical Director. And John was commissioned on behalf of the pork sector to look at emerging technology, including slurry cooling, some of the barriers to uptake, and actually how AHDB can really make a difference for producers. So without stealing too much thunder, John, I shall hand over to you.
Thank you, Ben, and good evening, everybody. So my role in GrowSave has been many and varied over the years. I've been involved since the very beginning, both as a researcher and presenting and publicising the outcomes through webinars and events such as the ones we're on tonight. The programme's been going for quite some time, since about 2007, and in horticulture up until last year, when it was expanded to encompass pork, dairy, cereals and potatoes as additional sectors to benefit from those shared learnings. It was recognised that quite a lot of the work that was being conducted in one sector would also benefit other sectors, and sharing those outcomes and making sure that the best practices were achieved across the board was felt to be very important. As we come into some of these sectors, we started out with some technology reviews, and that's one of the things that we will explore and talk about as we go through tonight. So yeah, just a sort of whistle-stop tour of what we've done under GrowSave so far. As I say, it's been mostly horticulture, but this gives you an idea of where we can go with the pork sector too. So it's mostly looked around energy saving techniques, climate control techniques, and emissions reductions. That's our core strength of the programme, to look at ways of saving money and ways of reducing harm to the environment. For example, optimizing air movement in glasshouses to make sure that you get uniform climate control and save energy on heating costs, etc. We also see as one of our key aims is to take ideas and explain them in simple terms, explain to people how they can be applied and what the benefits may be. And one of those things, as we talked about, is slurry cooling tonight. And we do that through literature, videos, seminars, study tours and reference sites, and all sorts of ways of getting knowledge across, because not everyone responds to the same way of information being presented to them. Next slide, please, Ben. As we said, we've started working with the pork industry since 2019. We're just coming to the conclusion of that first year of working with the pork industry, which has been a very enlightening experience for us, and hopefully so for AHDB too. As I said, we started with a bit of a technology review to establish what is the understanding out there in the industry, what is the levels of current practice, and what are the emerging technologies that we could be investigating further and promoting to benefit the industry. Specifically, we've been looking around energy and emissions reductions, electricity, the use of renewables. So you can't fail to have noticed the amount of renewable energy that this country has installed over the last 10 to 12 years. Slurry cooling, as we're talking about tonight, and that links into energy very closely, making sure that we use the resources that we have, as well as displacing fossil fuel usage and the like. And another example is LED lighting, but there's many more things in that technology review than those four. So I would encourage you to go and read it, and links to that will be in your handout as well. Next slide, please, Ben. So into what we're talking about tonight then. So what is slurry cooling? At its simplest, we've got something warm and we can cool it down. In cooling it down, we really have two major benefits. The first is reducing ammonia emissions, and we can see how that happens in a minute. And also it is a source of heat. When we're talking about resource efficiency, where on the one hand we're using fossil fuels to heat somewhere, why not use the heat that we can extract from other places and recover that and usefully apply it. The other thing to say, as Zanita has mentioned, there is the best available technique reference document, and slurry cooling is one of those best available techniques where it is deployed appropriately. And if you're a permitted site, then this is a document that you must pay adherence to. And there is a copy of that again in your handout. And I would also encourage you to read alongside this webinar the Cooling Pig Slurry to Reduce Gaseous Emissions Guide that AHDB have produced. So yes, you take the heat out of slurry, you also reduce the emissions of ammonia that it presents. It is possible to reduce that, the emissions from ammonia by quite some considerable amount, up to 75% reduction. That requires quite a high temperature reduction, and also the appropriate techniques and technologies to get the best out of that. Practically, and we'll hear from one of the technology propounders later on, practically we ought to be thinking about an emissions reduction of around 30 to maybe up to 50% reduction in ammonia emissions in sort of on-farm designed and well-installed systems. Next slide, please, Ben. As I said, it's important to refer back to the best available techniques reference document, especially where you're permitted, as you have to implement that as part of the document. Under that, one of the requirements is that the heat must be reused. It is not sufficient purely to cool a slurry to reduce your ammonia emissions. It's only a best available technique where that heat can be usefully deployed. And the places where you can deploy that heat are many and varied, but particularly on a pig farm, then farrowing pads, weaner accommodation, maybe even a bit of domestic heating or office accommodation. Those sorts of things are places where you might start to think about how you might use the heat. Clearly, as with most technologies, new builds are the easiest place to deploy this type of equipment. That's because you can put it in at the outset, you keep the capital costs low because you're not actually trying to change or alter ways of doing things that the buildings were not designed for. And in that way, you can also bury your pipes in the concrete floors to keep them out of the way and to make sure that they are well suited to collecting the heat from them. It is possible to apply this technology into retrofit. The only particular way of deploying it at the moment under the best available technique is through surface cooling fins floating on the top of the slurry. However, if you're not permitted, then there are other ways of retrofitting, such as embedding in concrete slabs, which I think Klimadan will be talking about as in part of their case studies later on. Next slide, please, Ben. So I guess the important thing is how much heat. Well, again, this depends on how much cooling you can apply to your slurry. And if you can get your cooling down to 5 degrees C, which I might say might be a bit of a challenge to get it down quite that low, there is potential to have up to 2.5 kilowatt hours of useful heat from that slurry per day. That heat, as I said, can be applied where it needs to be, but it could be supplemented with an additional heat source. So maybe it's a preheat of that heat into a building, or preheating water, and then you use some other heat source to take that to its final temperature, or to give you the total quantity of heat that you desire. To get the most benefit out of this, you need what we would call slightly higher than low temperature heat. Low temperature heat doesn't have that many useful applications, and 25 degrees C is something we might consider not a particularly useful temperature of heat. 50 degrees C would be much more useful in a lot of situations. In order to get there, a heat pump is required to take that heat from one temperature source to another. Next slide, please, Ben. As I say, heat pumps take one temperature of heat and turn it into another. Now, there's a bit of sort of witchcraft and magic that's claimed around heat pumps. Ultimately, most of you will be familiar and use a heat pump on a very regular basis, and considering your domestic fridge or any other type of refrigeration system, they are in effect heat pumps. And in this case, what we're doing is a cooling slurry, just like you might cool something inside your fridge, but we're taking the useful heat out of the back, out of the hot side of the system. There's a working fluid inside this, which is called a refrigerant, which you don't necessarily need to understand or work out how that exactly works. But basically, by going around the circuit, it expands, it contracts, and in that case, it takes up heat and it releases heat in different places. Importantly, we must talk about the efficiency of these technologies. And with heat pumps and refrigeration systems, we talk in terms of a thing called coefficient of performance, or COP. And that is a ratio of how much heat you get out to how much electricity you might have to put in to extract that heat. And a ratio of 4 to 1 is a sort of a typical efficiency in this type of application. That means you get 4 units of heat out for every 1 unit of electricity you put in. That doesn't mean that it is 400% efficient, because as we all know, you can't create energy and you can't make things more than 100% efficient. However, what it does mean is you get 4 units of useful heat out for 1 unit of electricity that you have paid for. And therefore, it is a relevant unit, a coefficient of performance, to have as a sort of a ratio of electric in to heat out. That assumes your source heat is free, of course. If you're paying for that heat, then that wouldn't be a particularly useful measure. But just remember, in terms of coefficient of performance, you pay for 1 unit of heat, you get the other 3 from your source, in this case from your slurry, or in other cases from ground or air. Next slide, please, Ben. So this heat can have benefit, as we've talked about. It can displace other fuels, be that for building heating, be that for water heating, be that for other sort of process requirements. Usually you are replacing heating fuels like oil, gas, LPG, and in some cases coal, and other types of fossil type fuels. And you're replacing them by applying some electricity. Now, clearly that means your electricity bill is going to go up, and the costs that you might be used to will be slightly higher. However, you've got to outweigh that against the fuel savings that you might be having on the other side. As costs go up, then yes, other taxes such as climate change levy come into play. and you are able to take advantage of the climate change levy discount scheme and get a little bit of a reduction on that, subject to signing up to energy efficiency measures, of which this technology is one. So they're another slight benefit in terms of your energy costs there too. One other opportunity, of course, here is that we can use these heat pumps to match excess renewable electricity, something we explore in the technology review in a little bit of detail about how you might sort of take your electricity when you've got a surplus of it and apply it to some useful purpose to avoid times of import when import is expensive. And where your system is combined with a ground loop, and if you get it in before March 21 or March 22, if you get a tariff guarantee, then a thing called the renewable heat incentive may also be payable to improve the economic benefit. There may be a follow-on scheme to the renewable heat incentive, which is something, you know, we've had the RHI now for about 9 or 10 years. People have got very familiar with that tariff payment. Well, the follow-on scheme is more likely to pay a grant, and it's more likely to be linked to smaller size technologies, and a £4,000 capital grant is what the government is currently consulting around. Now that may suit the introduction of this technology and pay for some of the capital investment that is required. Next slide, please, Ben. Let's say, where can heat be used? We've talked about this as we've gone through rather than dedicating a slide to it. However, there are some examples there of where heat can be used. As I've said before, water heating is one area where you need slightly higher temperatures of heat. So if you can't use heat at up to 50 degrees, hot water at up to 50 degrees, you may be boosting with electric immersions or other form of fossil fuel to get it to your finalized temperature. It is possible to get a higher temperature heat out of heat pumps. However, the payoff with that is a reduction in system efficiency. So where you might get 4 units of heat out down to 50 degrees and 5 units of heat out down at 25 degrees, you'll only get 3 units of heat out when you take that temperature up to 65. So you've got to make that cost benefit analysis to determine whether that temperature is worthwhile getting. Next slide, please, Ben. So that's me, really. That's sort of a whistle-stop introduction to the technologies and the techniques around slurry cooling. Klimadan is going to take us a little bit further in terms of some case studies and a bit deeper into the technology. However, I'll leave you with these thoughts. Yes, practical measures of cooling slurry take it from sort of body temperature down to about 15 degrees C. That's a practical application. And in that, you get up to 50%, but more likely 30% ammonia emissions. We need to put that heat to valuable use, farrowing pads, winter accommodation, domestic buildings, etc. And yes, retrofit is possible, even though it is easier to design into new buildings. We would encourage you to read and understand the best available techniques reference documents and make sure that you adhere to your permit requirements if you are trying to apply this technology to your farming system. And I'll leave you there and hope to catch up with you during the questions. Many thanks.
Thank you very much, John. Obviously interesting there to mention the duality of this technology. It's not just about energy efficiency, far from it. It has much more application potentially when it comes to environmental concerns around ammonia. So we're joined now by Kasper Holgersen, who is from Climadan. Kasper's going to run us through Climadan's background, their experiences with different slurry cooling installations across the continent, and obviously where they have experience in the UK. So Kasper, over to you.
Thank you, Ben, and good evening to all of you. Yes, as Ben mentioned, my name is Kasper Holgersen, and I have been working with slurry cooling only for 7-8 months, so I'm quite new, but our company have a lot of experience. The company is 40 years old, and we have been working with heat pumps, and we have more than 10,000 installations in Denmark with ground heating and sea and heating and everything we can do with a heat pump. We also have a division where we make slurry cooling for the farmers. Today we have more than 900 slurry cooling installation in Denmark and abroad. We produce our own heat pumps up to around 20 kilowatts, and then we have a cooperation with 3 European brands for bigger heat pumps, and that's what we are typically using when we are talking about slurry cooling. We have our own service organization in Denmark and some partners around the world. Normally, when we make installation in other countries outside Denmark, it will be our partner or maybe some local entrepreneur where we support them with one of our technical will be at the site and helping with everything. So we make sure everything is going as planned. One thing I forgot to mention, we also have our own engineering that is do all the calculation, and one of them in the beginning of this year, he have been working with working at Climaden for 20 years. So we have a lot of experience and knowledge inside the house regarding this slurry cooling. Next slide, please. Here are some of the countries we have made installation of slurry cooling, and hopefully we will also see in the nearest future some in UK. In China, we have a joint venture company called GreenMag with a local guy in China where we make the slurry cooling together with him. He provide the workers and we do all the calculation and everything. Next slide, please. Some of the challenge you have today in modern pig production is you almost know for sure the energy cost is going up. The environment is becoming more and more important, and the government try to prevent using cheap and high pollutant fuels. Animal and people's welfare is become more important, so that makes demands for good management. You have to use modern technology to be competitive, and of course you have to make a profit. And all these things, slurry cooling can help you to reach some of these goals. I'll try to show you some example. Next slide, please. When you shall choose energy source for your farm, what you normally have chosen in the past could be oil burners or gas burners or wood burners or something like that, and you know this kind of burner, so you are safe to make the investment in these, and typical it's a low investment, but maybe the running cost is a little bit higher for these because oil and gas is costing a lot of money today. Maybe a solution also could be biogas, but typical it's a higher investment and it's a large, bigger scale. You need to supply the energy for more than one farm, maybe some farms and some houses, etc. But that will be renewable energy. But renewable energy you can also make with a heat pump. The investment will be a little bit higher, but the running cost will be lower because, as John told, we will when we put 1 kilowatt of power into it, we will get 4 kilowatt of heat out of it because we will get 3 from the slurry. It is environment friendly and reduce the ammonia. Next slide, please. What can we use slurry cooling for, and why can we use it? We can use it to heat up the building. We can also make a combination where we also cool the building, maybe some parts of the floor, but I don't think you will use that in UK. That's more for where you have climate that's very hot at day and cold at night. You can also produce hot water with the slurry cooling. We can reduce the ammonia with up to 30% and sometimes up to 50%. We will reduce the CO2 emission because of we don't use oil and gas and etc. We will have more ammonia in the slurry when we spread it out at the field. In Denmark, slurry cooling is also approved at the technology list as reduction smell, to reduce smell up to 20%. Then we have to cool at the slurry every day a minimum cooling amount. So when we do that in Denmark, we will make some adjustments, so we are sure we are cooling the slurry every day. When you have a slurry cooling system, there's no work. You don't have to fill it with oil or clean it or something. It's just running. You save energy, and it's renewable energy. If you have it in a dry and technical room, it will be running for long life. You have a low cost of operation, and the return of the investment could be very short. I will show you some examples later. Next slide, please. This is just a picture of how it's working. The blue pipes is the heat from the slurry we take out of the slurry, and then we put it in the heat pump, as John mentioned, and then we have the heat water we can put in the stable and heat up the stable again. Next slide, please. Here you can see when we cool, the bottom of the diagram is cooling per square meters. In Denmark, we also use a scraper to take out the slurry. Then we can reduce the ammonia more, but I don't think you use that in UK. You only use the vacuum system. So it's the gray one. So if you see, for example, when we are cooling with 20 watt per square meters, then we have around 15% of ammonia in emission, reduced 50% of ammonia emission. Next slide, please. This is one of the stable we have made in Slovakia. You can see that when we make an offer for slurry cooling, we always make this return of investment, because we know the investment is quite higher than what you normally invest for your heating source. So to be sure you understand what you are investing in and the running cost, it's very important for us to show it, so you have everything so you can make the right decision. But this is for 2,200 sows in a food line stable, and the heat pump is only the heating source in this table. If you look, it's around 125,000 euro investment. You have the heat pumps, the slurry pipe, and the components, and then you have the supervision and installations. If you will invest in, it's written gas burner, but it's an oil burner, then it will be 25,000 euros. You have to buy a tank for storage, and you have some handling, so we have set that to 10,000 euros. So that will be 35,000 euros investment. The price for the oil is 0.9 euro. The labor work is 10 euro per hour. And the electricity is 0.09 euro per kilowatt hour. So you can see for this is a bigger one. So what we talked about before with the CUP on 4, this solution is 3.8. I think we is a little bit higher at the temperature for the heat for the hot water. And then if we take the next slide, please, then we can see what the total investment. You have to invest almost 100,000 euros more compared to an oil burner, but you save around 40,000 euro every year using the heat pump. So after 2.5 years, you have the extra investment is paid. So after that you save money every year. So it's a quite good investment to invest in the heat pump. Next, please. Next slide, please. Here you can see some pictures of when we put out the pipes for slurry cooling. The one is a little stable in Denmark, where there is a slower channel under the whole stable, and the other one is in China. So that it's very easy to lay down the pipes. It just have to be filled up. But in some stables, it's small, slower channels and all that. And we do a drawing, so it's easy for the people that is making the concrete to put all the pipes correct. It is very important all pipes, every loops have the same length. So we do all this calculation and support the people that's installing in the concrete. As you can see, it's fixed to the iron in the concrete on top of the sand. Next slide, please. And before we put on the concrete, we do a pressure test, so we are sure that everything is working as it should. Again, it's a picture from China, so it's a very big stable. Next slide, please. And this is a typical installation of a technical room. This is from Denmark, where we have put on there's one heating pumps, and again, it's very important. It's clean and dry in the room, because there's a lot of electronic in the heat pump. So yeah. Next slide, please. This is a bigger project we have in China, where we have made for 7,700 sows. There's 9 big heating pumps. We are heating up the whole farm, the administration building, and etc. There's put down around 60,000 meters of slurry tubes. Here we can for heat recovering, and we can also do some floor cooling, because it's very hot at the day and cold at night in this climate. Next slide, please. Yeah, there's a picture of the technical room. You can see it's a little bit bigger than the one we saw before. There's 9 heat pumps here, so it's a quite big project. Next slide, please. Again, a picture of the slowly cooling pipes that is laid down before the concrete. Next slide, please. Here's just an illustration of what we are cooling and what we are heating at this farm in China. You can see we in top or in the left side, you can see we also cool the air that is coming into the stable, and again, there's energy in the air, so we can use it to heat up in other stables where there's smaller pigs, and we are cooling also the floor where the sow is lying. So it's when it's very hot at the day, it can lay down there, and the floor is cold. We heating up the office, and we make hot water for the people that are showering before work and after work. Next slide, please. So that's hopefully it's give you an idea about what we can do with the slurry cooling. We can get some of the goals we want to, so we can have a farm where the investment is a little bit better, and we have focus at the nature and etc. Next slide, please. Yeah, thank you for listening.
Thank you very much, Kasper. Very, very interesting. Thank you very much for that insight into the return on investment and that calculation whereby you're comparing the cost of a traditional installation, for want of a better phrase, using gas or fossil fuels, and then of course slurry cooling. Obviously, slurry cooling as part of AHDB's commitment, as Zanita already mentioned, is just the tip of the iceberg. Obviously, as we move towards net zero and have to respond as an industry to particularly changing legislative guidance and probably consumer pressures, actually, for that mention, AHDB's proposed strategy is going to continue to deliver knowledge, resources and case studies, just like Kasper has highlighted, to continue to support producers in a changing world. Obviously, we'll open up to questions. If you haven't had a chance yet to ask any questions, again, I'll draw you back to the menu. There is the chat function there where you can enter your questions, and we will pass those to our assembled panels. Obviously, there are some that have come in already. John, this is really one for you. Unless slurry cooling becomes mandatory, which is obviously not something AHDB would push for. What do you think are the major barriers for producers in the UK in implementing slurry cooling?
Thank you, Ben. Yeah, it's a really interesting question, that. In my experience of looking at renewable energy and energy projects in general, you tend to find that mandatory gets done, and the next biggest driver is economic. And so providing a good cost benefit and return on investment will be the biggest driver for especially retrofit applications, where the complexities and the ability to harvest heat in the way that is useful and can be usefully applied will become one of the major barriers. I suppose I retain a hope that people do this because they are tied into improving the environment in the way that Zanita eloquently put it earlier on about reducing ammonia emissions and other things are important for the health of our population, just as much as for improving the health of our livestock and improving the efficiency of our farms. So yes, I can see the barriers being mostly economic, followed by so that the aspirational installations and providing a good justification for them.
Thank you, John. I suppose that leads us on to another question then, Kasper, which is really aimed at yourself. Given the need for a very clear economic case, i.e. a check of that return on investment, if a business wanted to investigate slurry cooling and needed to act quickly, what information should that business have readily available for yourselves in order to streamline the process?
Thank you for this question. One of the things we need to know is the heat demand for the stable, and maybe that already have been calculated by a ventilation company, or otherwise how many animals and how big the stable is, then we can do the calculation, and then we know the heat demands. And then we also need to know the area, the square meters of the slurry channel, because then we can calculate how much energy we have we can take out of these slurry channels, and then we can also calculate the investment, and then we can make a return of the investment, like I show you in this seminar.
Fantastic, thank you, Kasper. Another one, John. Obviously, AHDB is guilty sometimes of pulling information and research from a very traditional sort of academic knowledge base. Was there anything different in how you carried out the GrowSave report that perhaps make it more applicable or of the industry?
Yes, I think it's the way we approached the report was probably slightly differently to the way we would normally approach such pieces of work, and quite often you hear about people conducting literature reviews, and a literature review can come with a sort of sense of, oh, is that going to be a bit dry, isn't it? However, in this case, we actually approached a good number of industry figures, both farmers, producers, people providing technology, consultants, and even people that not necessarily in the industry as such, but would seem to have products and services on offer. And we followed leads, and it was quite often we started off talking to one person and ended up talking to 3 or 4 others as a result of that conversation. So yes, we did take a different approach to this. We lent our technical curiosity to the report, and maybe our slight cynicism as well, because we never take things on face value. We always want to sort of chart the depths a little bit to make sure that we are providing genuine, good quality information to people. So whilst we didn't include everything that we were told about, and there are many sorts of ideas, many ways that efficiencies can be gained, and new technologies that are new and exciting. Some were worthy of a brief mention, some were worthy of a section in their own right. However, probably the one thing that we didn't do was a literature review in any sort of great depth in the way that traditionally you would expect. We didn't trawl through hundreds and hundreds of research reports trying to find out a new nugget of information that hadn't yet been explored to its fullest. We spent more time looking at what's available here and now, what people are really interested in knowing about, to come up with something that is, as you say, of the moment, and hopefully provides a good bedrock of information and knowledge and case studies and all that sort of thing to go forward over the next 3 or 4, 5 years.
Thank you, John. So we've got a couple more questions coming in. This one from Matthew Wilkin. So I'll send this to Kasper first and foremost. So Matthew's asked, how does the cooling work? We're converting to free farrowing systems and are installing a slurry cooling system from Climadan. On days like this, the cooling would be very useful to attract the sows and piglets to different areas. So this is in particular, Kasper, your reference to the abilities to cool specific areas, such as for boars and sows. Could you give a bit more information on that specifically, please?
Yes, it will be a little bit technical, so please ask again if you don't understand. But we will make a buffer tank with a temperature you want to have in the floor. If that's 10 degrees, then when the heat pump is starting up, it will start to look at this buffer tank. Do we have 10 degrees in the buffer tank? If not, then it will take energy out of the tank. If we have, it will take energy from the slurry. And when you need the cool area, some places in the stable, then you will take from the buffer tank the cold water and then you'll put it in the floor. And you can use the same pipes you have in the floor to heat also. You can change the water, so you can put hot water in the pipes also. I hope that was answer to the question, or it makes sense.
That's lovely. Thank you, Kasper. So in short, the buffer tank almost acts like a fridge in conjunction with the heat pump, as opposed to delivery of heat. Just on that, if there are any questions that you feel we haven't quite answered, by all means respond to the contact information. And actually what we'll do is we'll take the time to provide more detailed insight. If we haven't answered your questions at all, get in touch and we'll make sure that we do. Thank you very much, Kasper. I have another one here from John McIlroy. Is slurry cooling a viable option on non-IPPC, i.e. sub 2000 finisher sow farms? I suppose this one, John, if I put that to you first, basically non-permitted farms, is there a point to putting in slurry cooling on a non-permitted farm?
Is there a point to it? I suppose it comes back to kind of what we were saying a minute ago about what would be the non-mandatory driver for people to this, or what would be the barriers if there wasn't a mandatory requirement. Is there a point? Yes, of course there is a point if you have a use of heat. If you are planning on cooling the slurry and sending the heat away to atmosphere, then the point starts to diminish quite rapidly. I suppose the moral obligation is to get that ammonia emissions down in the way that Zanita's graph shows that light green line, not really coming down in the way that people would like. So the point is to reduce ammonia emissions at a cost. Now, if there is a cost benefit in that you can benefit from the heat, if you've got a good requirement for heat, and maybe you can, if you need that extra temperature, you can supplement it with something else, then yes, there is a point to it. I suppose that there are other things that you can start to look at when you think about slurry and reducing ammonia. So if you don't have that heat, then there are other technologies. If you don't have the heat use, there are other technologies you might consider in preference. And I suppose one sort of aspirational thing for me is we start to think about all aspects of our farming systems as resources and not wastes. And if we can find some way of releasing, in this case, heat from our waste, or releasing other products from our waste and turn it into a marketable, valuable product, then that it improves economic benefit always round, as well as showing that we are trying to achieve everything we possibly can out of the inputs that we put in.
It's a good point, John. Actually, it's that duality of the benefits, isn't there? So there is the energy efficiency aspect, which obviously has a return on investment for non-permitted farms, and it may be, after a discussion with someone such as Kasper, John, that actually there is a return on investment that makes it an attractive option from an energy efficiency point of view. But actually, just to add to that, as we move towards net zero, even and actually especially non-permitted sites are going to share some of the pressures of the industry, either from consumers and retail, or from that legislation. And whilst we're not sure yet, obviously, of where those opportunities are within legislation, any investment does have to have an eye to what's coming, particularly under ELMS and various other things. So actually, there are benefits that we know, and there are benefits that we suspect may occur. So it's not just ammonia reduction that you want to look at for slurry cooling. You need to look and consider the move towards net zero and whether it could contribute in a cost-effective way as well. I do have one final question that's come in at the moment. I'll keep an eye out, obviously, just to see if there are any last. This one's again for John. Obviously, in terms of the report from GrowSave, was there any other conclusions about slurry cooling that's and how we're sort of looking to approach it as an industry that surprised you?
I suppose so. I'm guilty of being a dyed-in-the-wool energy geek in that sense, and I find some of these technologies fairly commonplace, and then you find a new application for it and people struggling with the concepts and with the ideas, and they're coming at the use of this technology from a different angle than the heat recovery or the heat use angle that I would have come at it from. And so yes, to see it being used in a sense to reduce ammonia emissions, and that is the main driver, so much more than the heat harvesting, I suppose, was surprising to me. the understanding of the technology, and I suppose I laboured a little bit earlier on about the fact that it's not black magic and it's not witchcraft. It's actually fairly sensible energy transfer from one place to another. And a clear understanding of how that works is something that I think needs to be expressed in simpler terms. And if I haven't got it right in the way that I expressed it today, then please let me know and I'll try and find a different way around of doing it. But where people don't understand technology, that becomes, as we go back to a barrier, that becomes a barrier to implementation. And I think we're on the fringes of that deployment, and making sure that it is a well-considered, well-thought-through installation that's well deployed in terms of the way that it's put into buildings, either new build or retrofit, and the instructions and the techniques for doing so needs to be very, very clearly thought through and applied.
Okay, we've got time for just one very quick question, as long as the answer, and this is again for John Swain, is fairly quick. Gary Haslam has asked if the literature review isn't necessarily part of the report, i.e. there wasn't a comprehensive literature review included in the report, how did we validate claims from suppliers?
I think I expressed that we're cynical people, and we have a relatively long-standing breadth of experience in the claims that people make, and we know when things don't sound right and feel right, and we have the wherewithal to check them out on a numerical basis. So yes, things were checked, but they may not necessarily been checked against age-old research reports in the way that other people might have expected.
I was going to say there were comparisons done on proven thermodynamic models, so the numbers were literally stacked up and scrutinised before any claims came through. Ladies and gents, because time is short, I leave you with the following. If we haven't had time to answer your questions, I do apologise. We will pick these up, anything that we've missed, and we will be in contact with you to make sure that we do answer your queries. If you have any further queries beyond the webinar, again, I refer you back to the handout. There are contact information for myself and Zanita in there. Please do contact us. You'll also get a feedback form sort of emailed over to you. It would be lovely to see how we can make these experiences better for yourselves as levy payers. And again, I remind you that we're going to leave the webinar in a moment. It will end rather abruptly. You've not been disconnected by mistake. This is coming to the end. So thank you very much for our speakers. Thank you very much for joining us. And again, please be in touch. Thank you and good night.